Good morning. Thank you guys for flying out to Atlanta, taking time out of your busy schedule to attend TechEd. I know it's a lot of things you could be doing at 8:30 in the morning, so I appreciate you attending. 5:30 for those of us on the West Coast. My name is Eric Hahn. I'm a program manager on RemoteFX. I work on the virtual GPU as well as performance, scale, and I work with some of our key server partners. So I'm excited to be able to present to you a lot of the work that I and my team have worked directly on. Today, we're going to cover the capacity and planning, and in order to do so, I want to first discuss it from the point of view of you guys. Why RemoteFX? Why is it important to you? How is it relevant to your environment? So I'll talk about RemoteFX, and instead of just showing you or telling you, we're going to have Wise give a demo from their thin client that will support RemoteFX. So in every case, I want to show you in yellow things that are demonstrable or actionable in your environment. We'll cover the architecture, which is necessary for the parts that go into the capacity planning and the performance. I'll explain the components and how they're interacting so that when we go into the capacity planning section, it makes sense. There'll be plenty of charts and diagrams to illustrate to you what are the trade-offs being made as we make different settings changes. We'll go through the actual capacity planning data. So there's going to be a white paper in June, so you're getting an early preview of content that's coming out. So as you go through, you'll be able to see what happens when the VM setting changes from multiple processors to single processors. What happens when I change the video or the system memory settings, as well as what happens when I change RemoteFX settings for capture and encode. Then we'll go through deployment considerations, things that as you guys are deploying RemoteFX or considering it in your environment, what are the key points for your servers and your environment, and how can you make the best choices through what we've already planned and worked with our partners. And then I'll have a nice summary slide with all the partners that have launched with RemoteFX. As you may know, RemoteFX launched in February of this year, and we have a partner pavilion booth downstairs, so you can go and talk to each one of our partners about what are the products they have that support RemoteFX. So when I think about why VDI or why RemoteFX, from your point of view, you guys all have cost concerns. You have pressures from both above and your customers. Your customers are the end users. At the same time, you have needs for compliance. So it's not hard to find slides like this or articles like this where some employee lost a laptop. It had 13,000 users data on it, and now it's gone. Right? So it's very easy to find this article. I can search for anything of laptop lost, and you'll find something to this effect. So you guys have a need for control, compliance, data access. It's a little more abstract to talk about it from the opposite point of view, meaning your users want productivity applications. They have certain expectations about how the interface looks. There's new data that renders in a certain way. So they want to be more productive in their environment, and you have the need for control. And as you look at the application sets, they're becoming increasingly rich. So you can talk about it from the multimedia and the 3D perspective. There's Microsoft and non-Microsoft technologies. Google Earth is something that people are using in their IT shops or in their knowledge worker sets. Flash, PowerPoint. So things that are just very commonly used amongst knowledge workers is increasingly rich from interaction, multimedia, conferencing systems. So their expectations are increasing at the same time as you have these cost and compliance concerns. So when you think about the applications that people want, you think about the pressures you have and what VDI can offer. Here's a couple case studies that we have recently with partners using RemoteFX, or customers using RemoteFX and what they were able to achieve. We have Convergent Systems. Convergent Computing is a consultancy shop in California. They wanted to keep their employees up to date, and they had employees come in for training every few weeks. That cost them travel time. They were away from customer clients, and they weren't billing hours. So for their need, they wanted to migrate first to Windows virtualization. And as they were using virtualization, they felt a need for more ability to do conferencing and video playback. So they were part of the beta for RemoteFX. And this is a quote from their president saying that because of RemoteFX and the technologies they deployed with RemoteFX, they were able to have a video conferencing system to train their employees, saving them $200,000 a year. And this is based on the billable rates that their employees were generating. There's also another case study that's, these are all publicly available. The Empire CLS is a chauffeur company. All their staff had 30-inch large screen monitors. And they had a need for certain software that they moved to VDI, were able to save 75%, as well as reduce energy consumption. So as they moved to VDI, they also had a need for USB redirection as well as video playback. And when they moved to RemoteFX, they were also able to see cost savings in terms of every end user terminal was about $2,500. And they were able to save that savings by moving towards a thin client solution. So as you have this need for control compliance, as your applications have a higher, richer set of workload, here's some case studies that illustrate for these people what they were able to achieve with this technology. Now, instead of me talking more about what is RemoteFX, why don't we have someone show you? Today, I'm pleased to have Hector from Wise Technologies on stage with us. Hector will give us a demo with the latest Zero client supporting RemoteFX. Thank you, Hector.
Thanks, Eric. Hello. So at Wise, so you may be familiar with thin clients. There's Windows-based thin clients, Linux-based thin clients. But one thing that we specialize at Wise is thin clients that don't have any operating system. Can you guys hear me in the back? Yeah. So what I want to show you today is a thin client that we have today. This is the R10L based on ThinOS and our Wise Zero engine. And this platform right here, what makes it so special is that there is no operating system on this device. What we have instead is a very small software layer, about 5 megabits in size, that sits on top of the hardware layer. And what that does is it brings up the network stack, anything you have plugged in, USB, keyboard, mice, or whatever, and gives you instant access to your remote desktop. What that allows you to do is no longer have to worry about kind of managing, securing, updating, patching that endpoint, and really focus your attention on how you're going to optimize your server and user experience for your users. So what we're going to do is connect two different sessions. One is a pre-RemoteFX VM. This is going to be just an RDP7 connection, which we support today. And then we're going to show you kind of some of the improvements that you can have when you move to a RemoteFX environment. And that'll be an update that we'll be having later this summer. So first off, let me do a quick restart here. So one of the beauties of not having an OS here is that this device will boot up, reboot in about 6 seconds. Also, every time it boots up, it goes and checks on a file server and makes sure that it has the latest configuration, latest firmware. So if you have 100 or 1,000 of these devices, the way you update them is you update one file or 2 files on your file server, and the devices will automatically update themselves every time they boot up. Like I mentioned, a lot of this is focused on so you don't have to worry about the endpoint. So if you deploy new boxes, new devices, you take them out of the box, you plug them in, and they're automatically ready to go. And you can focus on your server infrastructure. So let's go ahead and connect to this VM. So at Wise, we work very closely with Microsoft, so we're the only company that has RDP7 support on a Windows platform. So this right here is an RDP7 session, and we have support for all the main features, like here's multimedia redirection. We don't have sound in this room right now, but as you can see right here, this video right here is using the TS MMR functionality, which basically redirects this video directly to the thin client. So this video plays in full fidelity at 720p. But it's not using any CPU cycles to play this video. It's being rendered on the client side. That's one key item for also providing server scalability, which is a great feature of RDP7. But, and as you mentioned, RDP7 is great for most task workers and also for some knowledge workers, but it doesn't allow you, when you don't have RemoteFX, to do 3D applications. So for an example, if you want to do a 3D rich app like this application that lets you take a view of the solar system, you're not going to be able to launch that application because you don't have access to a GPU. Okay. So what you see as this tries to launch, it's going to tell you that, well, I don't have access to a 3D graphics engine, so you can't use me. So let's go ahead and launch a VM that does use RemoteFX. And we're really excited about this at Wise because we mentioned it basically takes the thin client story to a whole new area where before thin clients were kind of considered to be very
as mentioned, task worker-oriented or knowledge worker-oriented, but those that whenever you needed 3D apps to do anything more high-end, you would normally have to use a PC, right? And that kind of could increase the cost on the client side because you use more power, you have to manage and secure, things like that. So we're happy that now with the RemoteFX, you can have the thin client story and have that savings and simplicity, but also have the rich user experience. So once again, here, the application's already launched, and it's leveraging the 3D graphics GPU that Eric is going to talk about that RemoteFX can use. But you also get full arrow support, right? So all the user experience features that people expect when they're logging into a Windows 7 VM, you get that natively. Of course, the multimedia redirection will also work whenever you're doing flash-based video, which is very intense multimedia. RemoteFX is going to help encode that into a way that you can put it over the network and show it very beautifully on these devices. And also with USB devices, you plug them in, they'll be redirected. So it gives you the native RemoteFX experience. And I think, like I said, the big story is that you don't, to get that full RemoteFX experience, you don't have to have a Windows endpoint so now you have to manage 2 desktop environments. So with our ThinOS devices, you can have RemoteFX and not have to worry about the endpoint. Also, one really cool feature of our devices is, especially for the power users, I think the IT admins, people like this, is whenever you have more than one environment, you can quickly switch between them. You can use this kind of as your KVM switch for your virtual cloud, right? Okay.
That's great. Thank you, Hector. When can people get the zero client? When can people get the zero client?
So this is available today with the RDP7 support. For those customers on maintenance, they get an automatic update to have the RFX support, and that'll be coming in beta early this summer with a release in late summer.
Great. Thank you, Hector.
Sure.
So we talked about why RemoteFX. Hector gave a demo on the why zero client. Next, I'm going to go into the architecture and provide or explain some of the key areas that help us with the capacity planning. So this is a block diagram. I'm going to build from the server side. I'm going to talk about the virtual machine within the server. I'm going to explain the concepts of what are the technologies enabling RemoteFX in the virtual machine, how it impacts your applications, go through the server architecture, and then I'll explain the client architecture. So from a virtual machine's point of view, you have a standard application. That's what's illustrated by this graphed diagram. So this is an application. Your developers in your shop do not have to change how they're writing an application. What they would write towards a standard Windows PC, a physical environment, it would be the same. There's no notion of, am I in a session? It's just an application, and this one might be loading the standard D3D9 DLL. Right? So your applications don't shim, they don't change. RemoteFX is the first to present a virtual GPU or a WDDM GPU within a virtual machine, and that's what's illustrated by this gray box, and it happens to have multiple components, a user mode GPU portion and a kernel mode GPU portion. So your application is executing against a RemoteFX virtual GPU within your VM. The rest of this gray box is the server. So if I have a virtual machine with an application and it's executing, RemoteFX is integrated into Hyper-V. So I'll have some integration components which are in light blue. These integration components manage the lifecycle and the provisioning in terms of how many VMs I can boot and how those VMs are allocated across the GPUs. So these management components talk to a main process on the server side, and a lot of the performance counters I'll show in a minute or later on in the presentation will be inspecting about the performance from the server side perspective. So RDVGM is this process that runs on the server, and there's an instance of RDVGM for every virtual machine, and it's managing the GPU operations or offloading the GPU operations for this virtual machine. So everything that the virtual machine expects and is able to perform without thinking is being handled by RDVGM on the server side. In terms of its RDVGM's function, we think about it in terms of 3 main functions. The first is render. So as the application is trying to draw, flip, as you're doing arrow peek, all those operations are getting sent in the virtual machine to its WDDM GPU across to the server, and RDVGM is calling the render operations onto a physical GPU. The key thing here is we're also able to share a single physical GPU across many virtual machines. So if I have one PCIe GPU I insert, many users can run on that GPU. I can also add multiple GPUs. So RDVGM and the management components are in charge of that assignment and those operations. So as I'm rendering, those commands are getting sent to the physical GPU. The next thing we do is, as a VM is rendering, it's drawing, we have the notion of capture. So capture, its job is to do as it describes. It takes a screenshot, almost, of what's occurring on the virtual machine environment. So render has this notion of a user's screen. Capture knows that a change has occurred. It'll take a capture of that screen change. And the important thing for capture is it's making that determination based on, did a present occur or did some render operation occur? So we're not going to spend cycles on capture and later processes if the screen is static. So we'll do a capture, and we'll do it intelligently based on when the operation or when the changes occurred. Once the capture occurs, we'll also do a differencing to look at the region of change. So if I have a large screen, we have a tile-based algorithm, so we're not sending the whole entire screen dumbly to the client, but we're looking at sections that have changed. And once we have a capture, we'll then encode. So there's sections that's changed. We'll encode that data, and we encode on the GPU. So later on, when I go through performance data, you'll be able to see why some of these operations are introspecting on the server and how they're introspecting on the GPU itself. So render, capture, and encode are operations that are heavily done in the GPU. So we're offloading that to the GPU as opposed to the CPU on the server. Encode has its own notion of performance counters and also settings. So I can set encode image quality levels to high, medium, low. And later on in the capacity planning, I'll actually show you data that says what's the network impact and what's the user impact when I change settings for capture and encode. And then I have, as I mentioned earlier, a RDVGM process for every virtual machine, thereby giving isolation. So if I have heavy operations for one virtual machine, it's RDVGM that's handling that and ensuring that there's some fair use across the GPUs on the server. And therefore, we can share, one server can share or support many users, as well as one GPU can support many users. And so this is the architecture. And once RDVGM is done with its render, capture, and code, it gets sent across back to the VM side and out over our virtual channel on RDP 7.1. In terms of giving you a summary, this slide is something that you'll have when you take home the deck. And it explains from every point of view what I just mentioned about applications calling standard libraries, that there's a management component that handles the lifecycle of RDVGM, and what's the operation that RDVGM is handling. From a client point of view, I want to explain what the architecture is so you can see why this single architecture is able to offload, or how it's supporting the server host rendering operations. On a client side, I have, as I mentioned, RemoteFX is a graphics virtual channel. The RDP traffic comes into the client, and on one of the virtual channels, or the graphics virtual channel, is the RemoteFX data. We have an abstraction layer that allows us to handle decode operations on either the CPU, if the client supports it, the GPU. So if you have a client that you reprovision with WinFlip, it may have some class of GPU and you want to reuse it. So then with the decode abstraction layer, you're able to send some of those operations, or the client will decide for you, or the software will decide for you, to decode in the GPU. And also, you can have custom ASICs or custom decoder chips that our partners are building and supporting that will also take care of the decode. So you can have a thinner profile client. So these operations can occur in the CPU, the GPU, or some specific chip handling RemoteFX. And the key thing here is that the output of these decode operations is a simple bitmap. So this bitmap is what allows us to handle on a wide class of thin clients. It doesn't have to be something intense, but it's something that we were able to highly encode data, send it over to a thin client that then is able to decode it in the appropriate engine and output something simple that the user can see a rich experience on a thin client. So in terms of the IT monitoring control, I'm going to walk now through a server, show you the performance counters, also show you the group policy settings, and then actually give you a quick video of how we were able to monitor using monitoring using performance counters the end user's experience. And that will help explain the capacity planning data that I'll show afterwards. So here I have Hyper-V. I'm looking at my virtual machines. And I have multiple virtual machines running. The one with RemoteFX, I've added the RemoteFX GPU. And I've configured it to have a certain monitor resolution and a certain number of monitors. And this is part of the provisioning process or the reservation process we have in terms of trying to guarantee that each user has a rich fidelity experience. So what the IT admin has done is, or what I have done as the IT admin in this case, is I've taken a VM and I've given this VM a 1900 by 1200 monitor, or a single 1900 by 1200 monitor, and RemoteFX will provision the sys server accordingly to ensure that this user or I as a user have the right experience. Now that I have the VM configured, let me show you also some of the performance counters that we have. On the server side, I can look at performance counters and also on the virtual machine side. The server side, we can look at some of the key counters I'll show you are, I just mentioned capture as an operation that occurs in RDVGM. So this is a performance counter that's reporting out what capture sees. So capture monitor 1 is saying that on this monitor, I'm seeing this frame rate. And this is useful for as you're watching or you're trying to provision and diagnose a system, and you want to see what's the frame rate the end user expects or is actually seeing. This is a performance counter for you to go back and look at it. And it's based on, as I mentioned, how capture is capturing when the screen changes. So if you have content that's outputting at a certain rate, that's going to be governing what the capture frame rate produces. If I have a static image, the capture frame rate will be nil. If I have something that's doing 24 frames per second, I'll have the screen rendering at 24 frames per second, as well as some other frames that occur because of the way we tile. The encode operation, as I mentioned, and compression, we report out the compression ratio as well as the output bytes. We also have two counters that are relevant in terms of the way RemoteFX is working is that we're sensitive to sharing out the GPU for all your users as well as what's your client's ability to pull data. So if I have a client and it's only able to present at a certain refresh rate, we won't try to send data faster than that. So the client is actually pulling data from us. And we can monitor that on the server side. And the reason that's useful for IT admins is that you can then see from a distribution point of view, is it the server side, that's what's the frame rate the server is reporting, as well as how quickly is the client able to pull data. So what I'll now show is we have two counters here. One is waiting for client. So this is a clock interval or a count interval where on a per second basis, how many times were we waiting for the client to pull data from us? And maybe the network is slow. Maybe the client is not processing. So there's many reasons why the client may not. But at a segmentation point of view, you can use this counter to diagnose your system to understand where is the operation being bottlenecked. And there's also delayed frames per second. And delayed frames per second is really saying, did I send a piece of content within 140 millisecond delay? And this is more trying to account for what's the distribution or what's the characteristic of the frame rate from a frame rate and a jitter point of view. So here's I'd have to say, this video is not Hollywood quality, but I think it gets the points across. What I have here is I'll have two thin clients and a server. So this is an environment that we had back at the lab that was easier to film and bring to you than set a multi-machine environment here. But I have one server with a virtual machine, and I'm going to connect to the same virtual machine twice. The first time with a thin client, the second time with a different thin client. And I'll use the performance counters on the VM side to show you, or I'll play a video on the VM side to drive the data, and I'll show you the performance counter on the server side. And when you go back to your labs, you'll be able to use the same counters to get a sense of where the operations are occurring or how the data is being presented to your user. So this is showing you that I have a virtual machine that I've connected to. I'm going to play a video. You've probably seen quite a bit, Big Buck Bunny. It's an animation, and it's not using MMR in this case. We're actually host-side rendering through RDVGM all the video content. So this is going to be a thin client, and these two thin clients are set to not use MMR. Or actually, I believe these thin clients didn't support MMR. On the network output on the lower right side, you can see that I had a lull in traffic where it dropped. So I was looking at the network counter from the client side. Let me pause for a second. And that network counter dropped to 0 because I wasn't sending any data. The moment I hit play, the counter actually jumped to 22 megabits per second because I actually had the VM set to have the maximum experience. And that video happened to be able to output that amount of data. So then I'm going to connect. I've connected with a thin client. And on the server side, I'm going to show you I'm going to show monitoring of that thin client and the experience that your user is getting. So for lack of a better term, I've called the first thin client the 24 frames per second client. And what I've done is I've loaded that capture performance counter that I showed you. And if you may not be able to see at this resolution, I apologize. But if you click there, you actually see that it's getting somewhere around 24 frames per second. And it's because the video is able to output, the client is not. And there's the waiting for client counter. The waiting for client counter was also reporting 2 to 4 ticks per second. So I'm outputting 24 frames per second to a thin client. I'm rendering on the host. And as an IT admin, I can see that user, or this counter is a per VM counter, so I can see that VM1 is getting 24 frames per second. And I can also see that the waiting for client counter is very low, and therefore I know that the operations are actually not being stalled by the client in any way. So then I'll take the same VM. I disconnected the VM. I connected with another client. And for a lack of a better name, we call that the 15 frames per second client. So this is another thin client that has a very good experience in the sense of what it's able to produce. But it's producing 15 frames per second. It's the same VM. It's the same video playing in a loop. So I haven't really changed anything. I've isolated out those variables. I'm getting 15 frames per second with the same counter. I also happen to toggle through the delayed frames per second. It happened to be not showing much, which is not a problem. And then I looked at the waiting for client counter at the same time that I'm getting the 15 frames per second, and I'm actually getting, I was getting 14 polls per second. So Capture was looking at how many times it was able to send data, and then looking at how often data was idle there and the client hadn't pulled it off, and that's where I got the 14 count. So I'm able to, as an IT admin, correlate what's the user experience, meaning 24 or 15 frames per second, and I'm able to see whether the operations are on the server side, or in this case, on the client side. And with a breadth of clients, I'm able to determine which client was getting what experience. Right. So we talked about why RemoteFX. We talked about the architecture. Now let's talk about the actual capacity planning. So I'm going to explain how we test, and the reason for explaining how we test is I want to explain how it's applicable in your environment. So in testing, we have a standard VDI workload. It's a knowledge worker set. It has Office. It has Word, PowerPoint. With RemoteFX, we have this additional emphasis on multimedia. So we added more multimedia content based on surveys we've done, interviews with customers, and a lot of automation data that we happen to have. So we're taking a standard profile and creating a benchmark, and we need a benchmark to create repeatable results. The reason that this is, with the repeatable results, we're able to automate, and the important thing for you guys is that in your environment, your workload may be a little higher, it may be lower. So the absolute numbers I show in the capacity planning, it's not my intent for you to take back those absolute numbers and say, these are the absolute numbers you should have, but instead, I take the benchmark. We vary the settings on RemoteFX. We vary the virtual machine settings because you can then make relative comparisons. You can then say, with your scenario, which may be different, I can apply these settings. It made these differences in RemoteFX's testing. Maybe it'll make these analogous differences in my environment. So we have this benchmark. We constrain certain variables. Here we did not change, for instance, the CPU on the server. We did not change the memory speed on the server. you could at infinitum change all the settings you want, but then it becomes very hard to distill the data, explain the data. So we constrain a certain set of variables, and in our first publication of our capacity planning, we'll focus on the core capacity planning data that you can apply that's idempotent or applies to any environment you have. Right? So we run this benchmark. We run it repeatedly on different settings. And the important caveats are the data is based on the benchmark. So I wouldn't want to take the absolute numbers and say this is the absolute numbers you'll get in your environment. But the relative comparisons do apply. And also, hopefully they inform a pilot. So we highly recommend that you pilot in your environment to get the exact experience you'll see. And these are the standard caveats that you'll see in our previous VDI papers as well. So in terms of the knowledge worker scenario, we have Word, PowerPoint, WMV, Flash, and we also have 3D applications that run in loops as well. In terms of the terms, I want to use scalability and performance in a specific way, and I think this will fall within the norm. So in terms of scalability, I want to talk about it in terms of it's how we measure performance, or it's the performance values we get as we add users. So I can't really say that I've passed scalability results and had poor performance. It's really, did one user have good performance? I add 2 more users, did they have good performance? And at some point, my performance deteriorates, and we would say we did not scale to that number of users. So I'm increasingly adding users and measuring the performance. And as I mentioned before in the architecture slide, we do a reservation. So we reserve resources on the server side for the virtual machine, and that's based on configuration changes. And the resource reservation falls into 2 kinds. One is system memory reservation, which follows the Hyper-V standard, and one is the video memory reservation, which is introduced in RemoteFX. So the lower hand left table is saying, here's a system memory configuration. Hyper-V already does an allocation, which is 32 megabytes plus an additional 8 megabytes or so for every gigabyte that you give system memory to the virtual machine. With RemoteFX, we've also included the additional operations that we're taking, and we've increased it by a couple megabytes. And the resulting table is for, on a 2 gigabyte virtual machine, this is the amount of system memory that you would reserve with every VM. So this is a standard root reserve, is what they call it in Hyper-V. On the lower right-hand side, what I have is something that RemoteFX introduces because we're the first to have a GPU. So with this GPU, we're also reserving resources. If I have a single monitor, 1900 by 1200, I would reserve 220 megabytes out of the video memory. So if I have a 2 gig GPU, and I take, in all our tests, we were benchmarking with 1280 by 1024. A 2 gig GPU, the maximum I would get is 8 users. On this server, we had 2 gig GPUs. So the maximum we would get at 1280 by 1024 resolution was 16 users. So you'll see a lot of our performance is pegging up to 32 users with the 2 GPUs at 2 gig of video memory. And so the important point here is that RemoteFX is already doing reservations, and it's already doing guarantees to try to ensure a high-quality user experience. In terms of content, I mentioned we added content. We also had to add criteria to measure multimedia. In terms of VDI workloads, there's a standard input method that we do follow as well. And I won't go too much into it because it's something that pre-exists. It's already in the Windows 7 white papers based on prior to RemoteFX. But I'll explain it at a high level. It's really the idea that I have some types of user interaction where the latency is important. So I'm typing at a keyboard. I'm moving a mouse. Those kinds of input, I want a certain response delay. And what we have is we have an automation client, and we have an automated application on the left-hand side that talks to an automation client. It sends the keystroke. It goes over to the server side and actually the virtual machine. We record a timestamp, and we also send back the actual keystroke. And then we're able to record at 2 different points, or 3 different points, the start, when it occurred in the VM, as well as the response. So what we're looking for is, as we load the system, how is the response time changing? Is my typing and my response from that keystroke delaying to the point that it's no longer usable? And there's many classifications of input. You can do it for when I open, how quickly does the application open? When I do a keystroke, how quickly does the keystroke respond? And so this type of input method is standard, and it's an interactive form, and it's pre-existed, and we continue to use it in RemoteFX. There was an additional criteria that we had to add, and so as we go through the capacity planning data, you'll see that I refer a lot to the frame rate. If I'm playing a video content or I'm playing a PowerPoint video, there is the keystroke or there is the input that I do to initiate the video, but often after that, the key experience is what's the quality of the frames coming back. So if I have a 24 frames per second video content, what is the frame rate I'm getting at the virtual machine? So in the yellow, I'm trying to show that we have this, we're measuring a certain frame rate, and in the green, this would be the ideal frame rate where it's at an exact clock frequency. So I'm measuring the frame rate that I'm getting at the client, and this measurement occurs on the client side. Is my user getting 12 frames per second, 15 frames per second, or higher? And then we also have the notion of jitter. So jitter is really in between frames, how long was the delay? So I'm trying to characterize the distribution of the frame rate at that point. So is the frame rate 14 frames per second, but is it coming at a constant interval that would be what the user would expect? So the input method is something that pre-existed. The frame rate and jitter are something that we added, and it's heavily measuring the frame rate of video content or playback experience. It was a criteria we had to add to ensure a multimedia experience. We also have the resource method in the sense that we're measuring CPU, network utilization, memory utilization. So we also are measuring what's the consumption on the server side. So as I go through the capacity planning data, you'll see me show both from a user perspective, what are they seeing, and from a server perspective, what was the tax or what was the load on the server? Because as you're scaling the number of users, you want to know, did they have a satisfactory experience? And also, how many users could I project that out to? And what was the measurement on the server? So that's why we have both the user experience and the resource consumption. So I mentioned earlier that we constrain certain variables. In constraining certain variables, we're able to emphasize the variables that apply anywhere. Meaning, this table shows permutations that we did in our performance testing. The first box is, these are virtual machine settings. I varied the number of virtual processors from 1, 2, 3, 4. And I also changed the OS from 32-bit to 64-bit. So each comparison I'm doing, the first row represents 4 tests. The second row represents 4 tests that are comparable with the prior row because the first row was 32-bit, the second row was 64-bit, and I'm using static memory. So each time I'm creating a set of permutations that change one virtual machine setting, and you can actually see that I'm building a side-by-side comparison. So by the end, you can at least trace through and map it back to each other row about how one setting is impacting the other value. So we have the virtual machine configuration. I changed the virtual processor system memory. We also use dynamic and static memory. So dynamic memory is the feature that's shipped also with RemoteFX in SP1 that applies to RemoteFX and non-RemoteFX. And we also did tests using dynamic memory with RemoteFX. And then I also changed the architecture for, that's my way of saying I changed from 64-bit and 32-bit operating systems. And the last one is I changed the monitor resolutions. So these virtual machine settings, if your workload is different than mine, it's OK. These virtual machine settings are things you can do that apply to any environment. So as I compare my standard workload and vary these settings, you can see my delta. And then in your environment, you can map it back to a delta that you would hope to see, at least in a relative fashion. There's also the server side. So the server side are, as I mentioned, capture. I can control the frame rate. I could set it to high, medium, or low. I can also change the encode image quality level to high, medium, low. And so I vary these settings in the bottom set of permutations. And this is a way for me to then demonstrate for you what's the impact of server-side tweaks you can make or settings you can make and how they dictate the end user's experience. Right? The combination is actually quite large of what we produce. So both in the white paper and in this talk, we want to distill it to what are the key actionable takeaways. Right? You can start looking at some random counter here and map it to another random counter there. that's just too much data. So when we distilled analysis, we do look at things like frame rate. So this is a curve of 4 virtual processors for a 64-bit OS. And we look at the frame rate and the general trends. We can also create the jitter. We can create distributions using statistical analysis of how the distribution is occurring. We could look at changing. In this case, this is the CPU, and we can look at the the system memory being consumed. So there's a large ream of data, but in the next few slides, I want to distill it to the key actionable pieces. So what's the impact of virtual processors? What's the impact of the OS architecture? Does dynamic and static memory make a difference? As well as what happens when I change the capture frame rate, and what happens when I change the encode value or the image quality settings. So when I make my changes, what's the impact on these variables, and how does it apply? The white paper will go into much more depth about other settings, and it will also provide appendices of all the data. So first set of results. What's our recommendation, or what matters in terms of virtual processors? What I diagram here is, it's actually a distillation of 8 experiments into a simple single comparison. As I mentioned in our first row, we ran a 32-bit operating system with 1, 2, 3 virtual processors. The bottom blue chart is this 2 virtual processors, 32-bit. The second row in the table was 1, 2, 3 virtual processors for 64-bit, and we extract out the data for 2 virtual processors for 64-bit. So on a side-by-side comparison, I'm showing you a 64-bit 2-proc VM and a 32-bit 2-proc VM. So very comparable in terms of those isolated data points, same number of virtual processors. The only difference is what the OS architecture was. And as I mentioned, for us, we're measuring the performance as we scale the number of users, or as we add users. So the y-axis is the frame rate. I start out at 32 frames per second for the 32-bit VM. I start out at 36 frames per second for the 64-bit VM. And the x-axis is the number of users. So my first user count is 4 users. I then double it to 8, and I increase by 4 until I get to 32. 32 is the maximum on this server because I had 2 2-gig GPUs. I was using 1280 by 1024. So we do a reservation, and with this GPU and with this monitor configuration, this is the maximum number of users you would get, or this is the maximum number of users that would boot. And what we're seeing is that 32-bit, we're still getting with a 32-bit OS with 32 VMs, we're still getting a very respectable high frame rate, and there it's about 24 frames per second on this content. Right? So in this side-by-side comparison, we can communicate to you that there is a benefit, and that 64-bit is getting a higher frame rate. In terms of the dual processors, that's actually a longer explanation, but there's internal counters we look at, and we're able to see lower latencies. And we'll talk more about that in the upcoming white paper. Now, if I change the OS architecture on the VM side, is there a penalty, or is there a cost that I induce on the server side? And so on the server side, I'm looking at the total CPU utilization. And the y-axis is counting by hundreds, and it's really saying each 100 is a representation of a core. So if I took 100%, I took 1 core. So it's an easier way to explain to you how many cores I'm taking. And this server, if I remember correctly, it might have been a 12-core server, but the access only goes to 8 because we're only going up to 5 cores. Right? So what we're showing here is the green trend line is the same for 32-bit and 64-bit. And we're taking about 5 and 3/4 core of total CPU for 32 users. So on the right-hand side, we have a high frame rate. We have a higher frame rate with 64-bit. On the left-hand side, we're seeing that the trend is the same, and that we're not paying a penalty on the server side for having a different VM architecture. In terms of dynamic memory, the comparison yields a different result. The first is the blue bar is the static memory, static memory 64-bit, 2-proc. So it's the same as it's one of the tests that we ran in the last experiment. We had a 64-bit 2-proc static memory. This is a 64-bit 2-proc static memory, so you can do side-by-side comparisons throughout. And then we have a 64-bit 2-proc with dynamic memory. The dynamic memory was set to start at 1.5 gigs and run to 2 gigs. And here we're seeing that the frame rate is actually relatively, or statistically speaking, it's pretty much the same. There are some variances in the tests, but the trend line's the same. So there's not a meaningful a difference when I use dynamic memory and static memory, which is good, right? So static memory and dynamic memory, I'm getting the same result, at least on this, the benchmark that we're pushing. If I was actually to graph for you the dynamic memory and static memory allocations, so on the server side with the memory, it would actually just be a stair step, and it would be very static, and it would show you that I used to assign 2 gigs of static memory, so at 4 users, I have 8 gigs. So it would just basically show you what the reservation of static was and what the reservation of dynamic was. So it's not, it's a very static graph. In terms of the CPU utilization, we're also seeing that there's not a big difference in terms of changing dynamic memory and static memory. So on these tests, we're seeing that for a VDI workload with a knowledge worker work set with multimedia content, we're seeing that the CPU utilization and dynamic memory are all, there's no difference really for us. Right. Now, those were the virtual machine settings. What happens when I want to change the server-side settings? I could set the capture rate, and later I'll show you setting the encode quality rate. But if I set the capture rate, I could set it to high, medium, low. Right? So what we did was we had 32 VMs. We set all those VMs to high capture rate. We had another test experiment with another 32 VMs, and we set it all to medium, and then the last with low. And what we see is actually this content was actually able to push out this much, but we're getting an average of 39 frames per second when we set the capture rate to high. And when we set it to medium, we're getting an average of 37. And this is on the 4-user count, right? If I had a single user count, I might not see that much of a difference. But at 4, we're starting to see these kind of differences. And the trend line is going, as we expect, as we load the system, the trend line is going down. So at 32 users, we're seeing 28 frames per second for the blue line, the low capture rate. And we're seeing 31 and 32 users for the other two. So the frame rate is responding to the capture. And the reason that capture is, we created this policy is really to try to allow the admin to have some control on the system for, or allow the admin to have control on the system for how the GPU is, at what frequency the GPU is capturing for the end user. And that also reduces the workload consumption on the server. In terms of CPU utilization, since capture and encode, as I mentioned earlier, is a GPU operation, we're actually not seeing a difference on the CPU utilization. There are, each prior experiment, red, orange, blue, high, medium, low, is shown on the left-hand side. And what we're seeing is that the CPU operations, the bars are all the same, and there's the same trend line. So if you wanted to set a high capture rate and get 39 frames per second, your CPU, in this case, was not taxed. And that makes sense because we're using the GPU. In terms of the other server settings, rather than talk about every combination we have, we designed a set of experiments to say, let's maximize for your end user's experience. So this first row is, I want the best user experience, so I'm going to set the capture rate to high, and I'm going to set the encode quality to have the highest image quality. So this row, or this combination, is saying, what's the best user experience? The middle row is the default. So out of the box, the defaults are just set to medium. And for the sake of making all these side-by-side comparisons, we included an experiment to have the medium configuration. What happens if I want the opposite? What happens if my users are not as demanding, my scenario is not as demanding, I've tested, and I know that I don't want the highest frame rate? What happens if I set the capture rate to low and the image quality low? What is the result there? So the bottom row is trying to minimize the resource consumption on the server. What we see is that the frame rate actually mirrors the capture. In this set of experiments, if I varied the encode quality, but I set the capture rate to high, medium, low, I still see a high, medium, low with almost the identical values to the previous experiment. And that's good, and it makes sense. So before I got 39, 37, 32, And again, since I said capture to high, medium, low, I'm also getting 39, 37, 32. The only difference is with the red line on this graph versus the previous, I had the encode or the image quality set to the highest image quality in this chart, and the previous was set to medium. And then the blue line, I had the image quality set to low. And I will show you the difference in the encode quality, but from a capture point of view, how many frames I capture, how quickly I send those frames out, that has not changed. And so the results are consistent. But the actual content of the bitmaps is changing because we're changing how the encode occurs, or we're changing the quality level of the encode, and I'll show you what that looks like. But what's the impact to my network? We actually do see a difference. So if you change the encode quality, when you ask about network bandwidth consumption, the middle line, or the orange chart, is what's the default. So I'm getting about 2 megabits per user with the medium setting. Now, if I set to the best user experience, meaning high capture, the best image quality, I'm actually getting a 38% difference between the red and the orange. So the red is the highest user experience, the orange is the default, and there's a 38% difference in the network consumption. If I compare the highest to the lowest, there's actually a 91% difference. So the bottom one's around 1.4, the top one's around 2.7 megabytes per second. So I'm getting 2.7, 2.0, and about 1.47 megabytes per second per user if I change these settings to have the best user experience and the worst. So for your network characteristic and for your application scenario, that might change a little, but you can see the demonstrable effect and apply those relative comparisons in your environment. Now, what is the actual payload difference? If I set the encode quality, I'm changing to have a high image quality and a low image quality. And I'll try to blow this up as best I can on this monitor. But on the left-hand side, I have a low image quality. It's a desktop. So we have a picture of the desktop or an image of the desktop. This is getting sent over the wire because it's a thin client. The thin client is showing bitmaps. So here's a bitmap of a low image quality. In the right-hand side, I have a high image quality. So in a desktop, you may not see it so differently. Maybe in certain scenarios you have the pixelation or the exact image quality is important. So I'm trying to highlight between the two what's the difference. So if I zoom in on the region of where this image shows the computer tab, there's slight pixelations around the circles. Your user won't see the pixelation. The program is actually, we ran a test program that takes the low image quality and the high image quality, and it's highlighting the differences. So the intent is not that your user sees this pixelation there, but I'm running a program to try to show you, or I'm taking a snapshot of a program to try to show you what's the delta regions. And when I'm only showing you the delta regions, you can see that there's a slight change in variance in terms of the circles themselves. And to see the raw images of how they would look on the user, you would have to look at more closely at these two side by side. So there is a difference in terms of how the image is being converted and encoded and the bandwidth payload. And there is an image difference that you'll see at the end user's desktop. So we talked about why RemoteFX. We talked about the architecture. We went through the capacity planning data. Now, in terms of deployment considerations, what are things for you to think about as you pilot and use RemoteFX in your server environment? Our server requirements and we have a hardware requirements document that's linked in our blog. The hardware requirements gives you all the considerations you need for should I deploy RemoteFX, or what should I know as I deploy RemoteFX? And let me just distill it into 3 data points. There are 3 data points that we emphasize in our hardware considerations as you pilot RemoteFX. On the server, you want a SLAT CPU, so EPT, MPT on the processor. You want EPT, MPT is AMD and Intel's names for it, but you want it's a virtualization hardware assist that a CPU processor can have. Previous VDI white papers from Microsoft also talk about the importance of SLAT in VDI workloads. And for RemoteFX, it's actually something that we do a hard check against. Meaning if you have a server and it does not support SLAT, we'll do a detection and we won't boot the VM. Right? So it's that important that you have SLAT. And it's also something that's documented in hardware considerations, but I wanted to call out the key points. The next one is the GPU. So we add a GPU to the server, and that's how we offload the operations. And we actually have a whole entire set of logo tests around it. So the logo test actually is a little lengthy, so my key emphasis for you is not to know the logo tests, rather to look at the results of the logo tests. So with the top GPU partners, NVIDIA and AMD, they've gone through and done the logoing process. They've run these tests in their labs. And out of that, you can take a list of the GPUs that have passed that test. So rather than, it's something where it's just a much easier selection process for you. And so with the hardware considerations, those are all things that make sure you have a SLAT CPU and look at a supported GPU from the testing perspective. And the last one is also documented hardware considerations, and I'll go into it a little more here, is the notion of a baseboard management controller. So on your server environment, if you're using things like ILO, iDRAC, IMM, these are ways for you to, over the network, look at the server console. So that's an important scenario from our perspective. At the same time, there's an inherent incompatibility between the driver that chip runs and the GPUs that we're offloading to. So ILO, IMM, iDRAC, I'm calling it baseboard management controllers. These baseboard management controllers, their driver and RemoteFX, the GPU drivers that we run, cannot run side by side, both in RemoteFX and pre-existing RemoteFX. This would always be true. So we have additional enablements here where we added a cap driver. It's called the RemoteFX video cap driver, and it's described in the hardware considerations. And what that does is, if you want to still have your BMC functionality, we provided this cap driver as a way to enable some of the core scenarios without losing all the functionality. And the key thing you can do there is you can install a cap driver on the server, and it'll allow you to still run your ILO, IMM functions and iDRAC during the BIOS sequence. So if I want to flash the RAID controller, these are important from a server management point of view, and we understand that. And while we can't address what happens when the VM's running, you actually will not see the console display out from the BMC controller. We are able to help the situation during the BIOS sequence, as well as it also works in case of a blue screen. Now, all this testing that I mentioned and all these hardware considerations, it's trying to avoid a circumstance like this. So this is a slide that says, here's a worst case. I have a server. I have swapped one variable, which in this case happens to have been the GPU. And instead of getting a nice green line of 32 frames per second, I start tapering down to 5 frames per second, right? So we don't want you to have this. That's why we collaborate with our partners. That's why we build the logo program. That's why we do testing. And we do more testing than just the logo. I mean, the logo is an excellent set of testing, but we continue and invest with our key partners. And we're trying to avoid you from having to run into this experience where, because of one variable or the GPU, you get a much lower frame rate. And so it's the same server, same test, same configuration. And so the intent is, if you pick from the server catalog, we have this. If you search for server catalog, you'll see the Windows Server catalog. Here I clicked hardware, and the lower left-hand side, I see additional qualifications, and it says RemoteFX. There I'll see all the GPUs that support RemoteFX. And as of last week, the publication had 8. And over the next few days, you should actually see it double. And so the catalog is updating constantly. So these are GPUs that partners are saying support RemoteFX, have been submitted for testing. So from your point of view, it should be just a simple selection process. Right? Now, we talked about deployment considerations. I talked about capacity planning. And we talked about just simply picking up a GPU from the server catalog. I want to show you 3 server configurations that our partners are supporting, so that you can go talk to them today at the hardware or at the partner pavilion. These are servers that they're demoing, right? And there's a 4th from NEC, but that's only available in Japan, and the text is all in Japanese. So I only showed the English ones. So the HP ProLiant, they support the DL and ML370 on the G6, as well as the 460 workstation class. So they also have a GPU expansion blade. So HP is here, and these are photos. Some of these are in my office. And these are servers that are taking GPUs within the actual rack mount server. So it's it's a configuration you're used to, a rack mount server that I rack into an enclosure, and it's taking a set of GPUs, right? And they also have a whole entire guide that their engineers wrote about supporting RemoteFX. So it's linked at the end of my presentation. So when you grab my presentation, you can just click the link. But this is their guide for using the HP servers with RemoteFX. So it should be even more straightforward. Dell has several servers, the R710, the M610X. The R710 is a rack server. The M610X is a blade server. The M610X is the right-hand side. So it's shown in a M1000 chassis. And when you pull out an M1000 chassis, you see something that looks like the lower right screen. And that can take, that's an AMD 7800P. So it could take a passively cooled, no spinning fan GPU. Or it can take a riser card, and that's the middle picture. And that riser card runs or it's taken a host interface card. And that host interface card is a PCI connector to an appliance, and that's the left-hand side. And that left-hand side holds 16 GPUs. So I have a 16 GPU enclosure that runs a cable. The cable runs into either the R710 or the M610X. And on that server, I can input an interface card. And then, so the GPU can be external to the server, or it could be internal, as shown in the lower right. And so Dell also has a guide that I linked to that you can go download. And it talks about their testing with RemoteFX and the server choices that you have with Dell. IBM, this is exciting that they actually just released their white paper on Monday or yesterday. And so they have a IBM M3. It's a 2U server, and it takes 2 horizontal GPUs. And it's the M2070Q, which is NVIDIA's passively cooled, so there's no spinning fan again, GPU. And they're horizontally inserted. And if I open the enclosure, the GPUs will actually sit on the top upper right. And so I have a 2U server that this paper just came out, and it talks all about the testing they've done and their recommendations for building a RemoteFX system on IBM hardware. And this just came out yesterday. In terms of partners, we have a large partner pavilion downstairs that you may or may not have seen. And we have all the industry-leading partners. I talked mostly about hardware today because it was an IT Pro server-focused topic about capacity planning. But there's software partners, including Citrix, Quest. There's also WAN acceleration partners. So out of the box, RemoteFX is LAN support. And partners like Riverbed, Cisco extend to offer WAN support so that you can have a rich experience over the WAN. And then also, there's the thin client partners, Wise, ThinLinks, Cloudium, HP, that also support RemoteFX. And there's a series of ASIC providers for the decode chips like TI. In terms of related content, tomorrow, Karthik, who's up here, will give a presentation tomorrow afternoon about a deeper dive on RemoteFX and GPU virtualization. The capacity planning white paper, so I showed you a preview. I tried to distill the most actionable pieces. That capacity planning white paper will be released in June, and you can look for it on our blog, the team blog for RDS. Case studies, I showed 2 case studies at the beginning. There's actually, I believe, 2 more. So you can find it by just searching RemoteFX on the case study link. And in terms of server offerings from both the server hardware manufacturer and the GPU side, there's the HP, Dell, and IBM. So these are links to their reference architecture. NEC has one. If you look at the NEC page, it'll actually be in Japanese. And then the GPU offerings, AMD and NVIDIA have both announced and supported their GPU lineup, and those will also publish in the server catalog. So this is their corporate sites talking about their support for RemoteFX, and the server catalog is the testing backend that we've all done to ensure that you can just do a quick selection of which GPUs. So to summarize, we talked about case studies, the Wise Zero client, why is VDI important, or how VDI can apply in your environment. Hector gave a demo with the Wise Zero client. I covered the architecture for server remoting. So what does the server operations do? What's the components on the server side that get controlled by group policy, as well as performance counters. And then I have that summary slide that just gives an overview so you can just read it and look at some of those technical details. In terms of capacity planning, we talked about the testing approach. We tried to create a benchmark. We added additional metrics to that benchmark for frame rate and jitter. We talked about the user experience from a frame rate point of view. We also talked about the resource consumptions. And we gave some key takeaways about dual processor, 64-bit, dynamic memory. And in the white paper, you'll see that even more emphasis on creating this baseline configuration so you can do many side-by-side comparisons. In terms of deployment considerations, we made ecosystem investments in terms of working with our key partners, all the industry-leading partners, to ensure that, for your point of view, it's a very easy selection process. So please take advantage of all that work in the sense that talk to our partners, ask them about their servers, their GPUs, their thin clients. And all the testing we've done has made it so that it could be a very easy selection process for you. And in terms of reference guides, our server offerings, because this is a server talk, we have links in the next slide or in the previous slide with all the reference architectures. And please ask our partners about that. And please visit our industry partners, or the industry-leading partners downstairs. So thank you. My name was Eric. You'll find me later at the partner pavilion as well as the VDI booth. I appreciate your time, and thank you for coming to TechEd. So with that, we have some time for Q&A. I'm happy to, we have 8 minutes. I'm happy to take questions now or afterwards. OK, thank you, guys. Oh, please.
On the performance counters,
Yeah.
The capture rate, if you have like a video that's 30 frames per second and your thin client can only do 15 frames per second, do you see the capture rate actually fall then? Does the server respond to that?
That's a great question.
Delayed?
So the question was, if with capture rate, if the server could put out 30 frames per second and the client could not, what would I see? Actually, that video was actually that exact scenario in the sense that you will see the capture rate drop. And you'll see another counter increase. So you'll see the waiting for client counter increase, and you'll see the capture rate drop. And since we did a side-by-side test with the same server, same VM, same GPU, everything, we know that it was just one variable that caused that.
So wouldn't the wait for the client then drop also if the capture rate drops?
The wait for client is actually a counter that's incrementing. So it's trying to say, how many times when I polled did I have data and did the client not pull it? So just the way we communicate the counter is actually an increasing counter means more delays.
Sure.
So.
No, I just wondered if the server does respond and stops capturing, like, goes back to like capturing 15 frames per second, would it actually respond and be dynamic? Like
it is dynamic in the sense that, let's say, network can also cause this. If I cause network congestion and the data didn't get to the client, but then that network congestion went away, or some variable that can go away, let's say that happened, the capture rate would immediately respond. So capture is instantaneous. They're both instantaneous counters. They don't have history. They have a little history, but it's not minutes. Thank you. Thank you, guys. I'll be around for more questions. Thank you.